Okay, in this problem video, I'm going to have us do this in two stages. First, what I'm going to do is I'm going to say problem setup. And then as always, I'm going to have you start the problem. If you're stuck, I'm going to do a quick waypoint in between there and the answer, where I'll walk you through the steps you want to approach the problem with. And then we'll actually get to the solution. So there'll be two different pause moments here coming up. So let's look at the problem. So a 10-gram sample of an unknown ionic compound was dissolved. So we have some sort of a salt and we dissolved it. All right. All the solution is treated with enough silver nitrate, so there's excess silver nitrate, to precipitate all the chloride ion. So in this case, we're not actually trying to measure how much of the metal is present, we're measuring how much of the chloride ion is present. Okay, so we're going to figure out how much of the chloride ion was there by precipitating it with silver, which we know is a solid with silver chloride. The silver chloride precipitated out and gave us 30.1 grams of silver chloride. Is the compound NaCl, KCl, MgCl2, or BaCl2? So this is going to be my first pause and try it moment. If you get stuck, let it go for a second. Okay, if you were stuck, here's where we can break it down just a little bit for you if you're kind of overwhelmed. There's two different phases that we have to think about in this problem. One thing we need to do is we have to decide how much of the chloride ion we have. So if we know how much of the chloride ion we have, we also know the mass of the original sample that was chlorine. Once you know that, you know how much of the rest of the material was the metal. Then you can say, okay, cool, now I know the grams of the metal. I know the moles, either if it's a +1 or a +2 charge. And so I should be able to figure out the molar mass. Okay, so if that got you unstuck, great. Go ahead and pause and give it a try. Okay, now we're going to go into the actual solution for this one. Okay. Now, I'm also going to take a bit of a tangent in this one and remind us how to handle some of our types of equations for this. So not a big tangent, but it'll help solidify this a little bit. What we're saying is that right now we've got some sort of an unknown. There we are. For some reason it wasn't writing for me. So XCl plus AgNO3. My handwriting's a little bit bad today. The stylus isn't quite playing nice, but I think it'll be all right. And we're going to make some unknown thing, XNO3, plus AgCl, solid. This is probably good enough for us to get rolling with it, but we aren't really adding anything here saying that we don't know how many of these, actually we don't know what the charge is on the X, so we don't know how many of these or whatever we need. So N, I guess I'll just put, and that means we don't know how many of these we had originally. So let's actually get a little bit more specific than this. And for that, let's go for a total ionic equation. It'll help us visualize things a little bit better, I think. So for our total ionic equation, we're going to have some charge here, and I don't know what this one is. I'm just going to call it N. It'll be plus charge. And that means I'm going to have that many chloride ions attached to it, right? So if it's Na+1, it'd be Cl, oh, it would be one of the Cls. If it was like Mg+2, then it'd be 2 Cl minuses. See what I'm doing there? All right, so then we have our AgNO3, so Ag plus NO3. No, that's not even close to being legible. Single minus. All right, and then we have our, let's see, we'll have our X N plus still sitting there loose in solution. It didn't precipitate to anything. And we'll have our NO3 minus. And we pair it up with whatever we have there, right? And so we got that. And then we'll have our silver chloride that we precipitated. So AgCl solid. Now I like to use the equation as a graphic organizer for myself. So right underneath it, I'm just going to write that I made 30.1 gram of the silver chloride. We can see that right up here. So that's how much of our product we made, right? So what we need to do is figure out how many moles of that product there were. So let's go ahead and set up a little fence post for that. Now, before I do that, let's go ahead and just find my molar mass. And just to save some room, I'm going to put it right here. I'll do my molar mass calculation. We have Ag, we have Cl, there's 1 and 1, right, for this guy. So we have 1 mole of each. The mass for silver is 107.9 gram per mole. I'm going to leave that out just because my handwriting's bad enough right now. I'm going to go off the side of the screen. What it is that I'm on a multi-monitor and it's stretching my whole drawing stylus over 2 monitors. So I have to kind of, you see how my writing's a little stretched out. Anyway, that's neither here nor there. So chloride mass is going to be 35.45 grams per mole. We'd multiply that across, then add down. It's times 1, so I'm just going to do it right here in the same column, again, just to save some space. And when we go through that process, we'll have that as 143.35. And of course, because we all know and love sig figs, we'll remind ourselves addition subtraction rule, we chop it off there. So that 5 is not a significant figure at the end. Let's keep it around so we don't have round off error. So I'll just do a little drop cap notation on that. And let me make that a little bit more legible too. All right, so that's going to be the grams per mole that we have for our silver chloride. So let's set up the fence post for this. We had 30.1 gram of AgCl. So let's go ahead and figure out how many moles we have. So we have our grams of AgCl and our moles, AgCl. And if we go grab our molar mass, we figured out that's going to be our 143 point, oh, that's even worse there, 143.35 grams per mole. There we are. Now let's use our stoichiometry to say how much of the chloride ion we have. Now, if you're just rushing through this, and when you did your scrap work, you probably did, that's fine. I'm going to be really rigorous. We're going to have 1 mole AgCl, and I'm going to be extra rigorous by saying, let's figure out how much of the chloride ion we'd have. And it's going to be a 1-to-1 stoichiometry. Just looking from right here and right here. Okay, so we are now in the context of chloride ion. Now, I would say let's go ahead and find out this number so that we know how many moles of the chloride ion we have. Let's also go ahead and figure out what the mass of the chloride ion is. So I'm going to just extend it one more fence post after my answer. And let's put our 35.45 grams of, moles, grams of Cl right there, and 1 mole of Cl. What we're doing here is we're saying, if I know how many moles of chloride I have, I can use that to figure out the molarity in a minute. The mole ratio here in a minute. But I also want to know the mass of chlorine I have, because if I know the total mass of that 10 grams that's chlorine, the rest of it's got to be the metal. And then I can try it as either a +1 or a +2 metal and figure out what my actual molar mass will be, right? Okay, so let's go ahead and we'll just quickly calculate this waypoint right here. I'll skip doing the calculator step right there and just write it down. So we have it as 0.1, oh, let me clean that up, 0.210, and then ends up having an extra insignificant figure hanging off the end that's still also a 0, and that'll be in terms of moles of Cl. So the moles of Cl will cross cancel here. I didn't finish my cross canceling earlier. These two cross canceled. These two cross canceled. I was in moles of chlorine right here, and now I've just cross canceled that to get to grams of chlorine right there. So then we have this extra part B kind of answer, right? And when we find that, we'll get off of our calculator, we get 7.444 grams. So let's see, I had 3. Actually, no, I should leave that as 3 sig figs. So let's leave that up here. There we are. So 3 sig figs grams of Cl. And I'm not going to worry if it's Cl or Cl minus right now. We can treat them as being the same as far as figuring out how much mass we have, right? Okay, so out of that 10 grams that I had, 7.44 grams were chlorine. So if I subtract those, I find that I have 2.56 grams of my chlorine, of my metal. I was writing a question mark. I already listed as N plus. There we are. Let's stay consistent in the problem, right? So we'll have that many grams. Sorry. Oh yeah, I do have the G. Let me just make this more clear. Like I said, I know my handwriting is worse than usual on this video, and I'm sorry about that. All right, so here we are. We have grams of the metal with some charge. Okay. Now notice we know the number of moles that we have of chlorine, which means we can figure out the moles that we have of the metal for either one of these cases, where we have the +1 metals or the +2 metals. So if it's a +1 metal, then we're going to have our 2.56 grams, and that's going to be paired up with 0.210 moles of the metal, and that would give us 12.19 grams per mole for whatever our metal is. Now, there's nothing in the +1 or +2 metals that's matching up with that molar mass. In fact, obviously not much of the periodic table does, right? There's only a few elements that it could be even close to. That looks close to carbon's molar mass, and that's definitely not what we have as a metal, right? So let's try out the +2 metals. So for this, we're going to do the same thing. We'll have our 2.56 grams, but if it's a +2 metal, there can only be half as much of it as we have the chlorine. What I mean there is, remember, if I have MCl2, whatever number of moles I have for the chlorine, the metals have to be half of that, right? So we're going to use half of that number, so 0.105 moles. And when we grab our calculator and type that in, I'm going to clear that out so I have a spot to write, we'd get 24.3 grams per mole. I'm not worrying about sig figs anymore, because really at this stage what we're going to do is grab our periodic table and say, does this match one of our 4 candidate metals? And sure enough, magnesium is 24.31 on the periodic table that I'm looking at. So that gives us a pretty solid answer for that. So based on that, we could say that this must be the identity of our unknown salt. Now this is a bit more complicated than a lot of the gravimetric analysis problems that you might run across, because it really does have that extra middle kink in it where you have to think around a curve. Usually with these, we're going to be solving for how much of the sample was there, or how much of the analyte, the thing that we cared about in the sample, was there. But I wanted to show you one that was a bit more complicated in this, so you had something to really test out your knowledge and play around with the numbers a little bit.